All right, we're back. We're on page 4 of notes 4 of Calc C. We're talking about introducing series. This is going to be the first series test. I think there are maybe 11 series tests that we learn. I don't really know. The first one, however, series test number 1, is about geometric series. All right, so geometric series are going to be one of the most popular type of series that you learn. And that's good because they're also one of the easiest to work with. So a geometric series with ratio r has the following form. So it might be that you start at 1 and then you have n minus 1. Also, all of these are like really huge oversimplifications of what's like actually happening, but that's okay. So n equals 1 to infinity a, which is the first term, and then r to the n minus 1. So what's going to usually happen is that your first term here, well, actually, this will always happen. Your first term is generated by whatever number is down here. So when n is equal to 1, we get n minus 1 is 1 minus 1 is 0. R to the 0 is 1. So you actually just get a, which is where a is coming from. And then you take this and multiply it by r to get a times r. You take this and multiply by r to get a times r squared. Take this, multiply by r to get a times r cubed, and so on. So if you have the summation, you can work your way backwards to figure out, if you have the, what is that? The written out summation, I guess? If you don't have the summation notation, you just have the sum. If you have the sum, you can find r by doing this term divided by this term, or this term divided by this term, or you could do this term divided by this term and know that it's r squared. There's like a lot of things that you can do. So that's if you started at 1. If you start at 0, it looks a little simpler, and it, honestly, in my experience, I think it's the way it's shown more often. So when n is 0, you get r to the 0, which is just going to give you a, which gives you your first term. 0 to infinity, and then you just add them up. Same deal, right? So a can't be 0 because if a is 0, you're just adding up 0 over and over and over again, which is obviously 0. It's not really geometric in that case. So convergence and divergence. If the absolute value of r, is greater than or equal to 1, the series diverges. If the absolute value of r is less than 1, the series converges. That's all there is to it, right? So this is probably one of the easier ones to deal with, but you got to remember it. So when it does converge, so first you have to figure out what r is. Once you figure out what r is, you figure out which of these is true, then decide if it converges. If it converges, the absolute value of r is less than 1, the thing is going to converge to a over 1 minus r. I think it's easier to remember this as the sum is the first term over 1 minus the ratio. First term, 1 minus the ratio. First over 1 minus the ratio. I think that is the easiest way to do it. But you know, however you want to remember it, you just have to remember it. The reason I like to think of it as first over 1 minus the ratio is then it doesn't matter what number someone is trying to make this start at. Like if this was 50, go from 50 to infinity, I would just take 50 and plug it in, and that would give me the first term. And then the ratio is just r, and you kind of know what to do. So let's see if we can do these. They're mostly calculator. So what can I fill in without the calculator? So here, r is definitely 4/5, right? Because it's a and then r to the n. So I know that it's a, r to the n, I guess. I don't know. R is 4/5 in that case. The absolute value of 4/5 is less than 1, so this definitely converges. And it's going to converge to the first term. So the first term is take 0 and plug it in here. So 0 gives me 1, right? 4/5 to the 0, and 6. So the first term is 6 over 1 minus the ratio, which should be 30. Calculator will confirm or deny or refute, I guess. Confirm or refute, whatever. All right, so here, the thing being raised to the nth power is r, so 10/9. Now 10/9 is greater than 1, so this diverges, which means that there's no sum. Here r is 1/2, which means this definitely converges because 1/2 is less than 1. And then it should be, so we take 1 and plug it in to get the first term. 1/2 over 1 minus the ratio is 1/2, so that's 1, or should be. All right, here we're doing 0.7 is being raised to the nth, so 0.7 is r. That's less than 1, so this converges. Now the first term is what happens when we plug in 3, so 0.7 to the third. over 1 minus 0.7, which I don't want to work that out. It's like 3 to 49 over something. I don't know, something. No, not even, because of 3. The calculator will tell us. All right, so for this one, we have to figure out what R is. So if I do this term divided by this term, it should give me R. So R is -3/2. Then you can check it and just do, do it again. So do this term, 9/4, divided by this term, -3/2, which gives me -3/2 again. And so you can see -3/2 is R. The absolute value of -3/2 is bigger than 1. So this diverges, which means there is no sum. And now we're going to use the calculator to find the partial sums and then be done with this page. So all calculator from here. If you know what you're doing, go live your life. So I'm gonna, what am I doing? The sum from 0 to, so first just 0 to 10, 6 4/5 to the n, control enter, so 27.423. Fill that in. Then we do 100. I don't know why I always do that. I always do 10 and then 100, as if those are, 30. 3 decimal places, we get 30 already. Then we know if we go to infinity, it's going to give us 30 because we worked it out. But still, let's do it. Infinity, 30. All right, so change it up. Now, the thing is, finite sum, right, where you're not going to infinity, always has a sum. Like you're always going to get a number here. So 2, 10/9. You get big numbers depending on what you're doing, but so 35.424. Now we're going to go to 100. It should be a lot bigger. Yeah, that 677,659. I don't know. 677,659. So there's always a finite sum. If there's a finite number on top, it's got a finite sum. It's just because this is spiraling out of control because 10/9 is bigger than 1. The number's going to be enormous. Like if we tried 1,000, it's probably, I'm not going to do it. I really want to, but it's too big. Let's change the next one. It just gets bigger though. So this is 1/2 to the n. So 1/2 to the n, yeah. So decimals maybe? 1 point, wow. This one converges and converges really fast. So the next one I'm sure is just going to give us 2, which is not what I got when why did I get it wrong? Oh my gosh, what am I doing? This was supposed to be 1, which gives us 0.999. So that's a really easy fix. So it does look like this converges to 1. I was thinking I don't know. There's a lot that can go wrong when you do these. This rounds already to 1. So the next, you gotta look alive on these. There's gonna be 0.7. So I'm doing 0.7. If I did, we're supposed to start at 3 for some reason. So 1.077. If you use 7/10, you'll be able to get an exact value of the sum instead of a decimal. I don't know if you care about that, but if you put a decimal anywhere, you just get a decimal no matter what. There's nothing you can do about it. If you can find a way around that, you can like tease the exact value out of these things. So here I'm gonna get, so I'm gonna go to infinity and you'll see I just get a decimal, but it's gonna give me a decimal. So same one, 1.143. If I make this 7/10, then the calculator will do the exact value, 343 over 300. So just something to know. I mean, I don't know if you need that or not. So for the next one, we sort of have a problem because it didn't give us a summation, but we know how to write it. So what we're doing is n goes from 0 to, first to 10, I guess. The first term is 1 times the ratio is -3/2 to the n. And now if n is equal to 0, I get 1, which I should. If n is equal to 1, I get negative 3/2, which also matches the written out sum that we were given. So here we get 34.999. Wow. This diverges. So the next one going to be even bigger. Or it might, well, the absolute value will be, always do control enter. The absolute, no way, not writing that. What should I write? Infinity? I don't know. I'm gonna write too big. Just two, like the words TOOBIG, exclamation point. So that one definitely is spiraling out of control. We already knew that though, because the absolute value of negative 3/2 is bigger than 1. It's actually a lot bigger than 1, which is why it gets really big really fast, versus like 10/9, which we could at least fit in the box and it could at least write without scientific notation. But anyway, these are all geometric. Being able to find R for a geometric is a big, big deal. The absolute value of R needs to be less than 1 for it to converge. If it converges, just first term over 1 minus the ratio. And they're really not that bad. So this is one you want to master as soon as possible. And we'll be back in the next video to probably do more. So see you there.